Hi, everyone. Thank you so much for having me here today. Good morning, good afternoon, and good evening, everyone. My name is Supriya Raman, and I work in Payments Technology Group of CIB, Corporate Investment Banking in JP Morgan, as Data Analytics Officer. Primarily, my work is on strategic data solutions where we collect, analyze, store, and use the data in order to achieve our business goal. In the session today, I will be primarily talking on the generative AI and LLM models in the banking industry, which are inspired from my approved deliverables for large language model. Before we implement this technology, we ensure we use appropriate controls and we use the AI technology ethically and responsibly. We will start with a brief introduction of generative AI, and I'll cover up some external landscape, and then we will then discuss about some of the use cases in banking industry, primarily how the AI can be used in order to improve the productivity. Um, so I have these examples will be apt here. Primarily, LLM are meant to be, the text generative models, rather than predicting the next tokens or the words in the series. If you check up the examples here, the first example talk about this is a glass of orange what, and the next token is easy to guess through because it will be juice, and how we came up with the word juice is we might be relating it with the previous word orange or maybe with the glass. Also, the next example is about the clouds are in the, and again it is easy to guess through because most of us will answer it as sky, and we might be relating it to the previous words cloud. But in the final example which we have here, I will quickly read it through. I met this French girl Emily in a conference last year. We fell in love instantly. My parents are conservative, so I planned and organized a blind date with my parents. They loved her. My mother hugged me right after Emily left. Even my dad gave me that rare wink. I'm so excited. All that is left is to convince Emily's parents. Here I'm booking my ticket to Dash. Now, as a human, it is quite natural, and we most of us will be able to predict the token as France. And how we came up with the next token as France is we will be primarily referring to the first few words in the first sentence, which is French. But when we do text analytics, referring back to such context and referring back to such um, series of tokens behind, it becomes very complex. And that's why text analytics is not only complex in dealing with the content, grammar, and the context. Also, many a time it's a very biased way of reading through it because it also involves human sentiments. um, I'll quickly set up some scene here by giving a quick intro. So any kind, which can be either text or image or sound or anything. And when we talk about LLMs, these are pre-trained models which are trained on huge amount of data, and they are very specialized to do common activities like specifically talking about the text, we can do summarization or text generation or translations. Are all LM generative AI? So no, not all LLMs are generative AI. Some of these are also NLU, which is natural language understanding. And finally, what are the different type of models? So most of the text-based models which we are using today in LLM are transformer-based model or the encoder-decoder-based model, while the image or the different type of contents which we have, they are mainly diffusion models. So these are some of the very common use cases of the transformer model. And the large pre-trained transformer model, specifically again talking about the text, they are trained to predict the next words, or more precisely talking, it is token, given some input text, right? So here are some of the common use cases application. LLM are used to generate long form text generation. They are also used for performing abstractive and extractive summarization of huge text or document in order to extract the essential nutshell. Some of these use cases are very specific, like name entity recognition in order to acquire and process the data. And we can either go with, when we are doing name entity in recognition, right, we can either go with already labeled data, or we can build up one from scratch based on the use cases. LLM can also be used in order to invoke the API, and the primary way to interface LLMs with external APIs are either by using functions or by using LLM generated interfaces. So when we talk about the LLMs, specifically again in the text context, they are mainly transformer models, and transformer models are based on encoder and decoder architecture. Some of these are encoder only model, while others are decoder only, and we can see in pictures some of these models are both encoder and decoder based. One of the major differences between these two terminologies is that encoder gives binary code as an output, while when we talk about decoder, it receives the binary code, right? Also, encoder only model are specialized in understanding the context, while decoder only model dwell on the art of creative generation. Choice of which model to choose when we are designing our own LLM application, right? It requires a thorough understanding of their functionality and the architecture about how they have been built up. When we talk about LLM model to be integrated into our own applications, we need a very powerful framework for developing NLP applications using LLM models. And it simplifies the development by providing standardized interfaces, prompt management, and external integrations. Primarily, if we talk about generative AI software stack, it can be summarized into four levels. The first being the main component, which are LLMs or APIs. And we have LLM, which are specialized in text and images and musics and sounds and all sort of contents. The second component is about the vector database, which provide a way to unlock a new level of performance by allowing the LLM to access the database more semantically. And third is the deployment platform, which are primarily the public clouds like AWS, Azure, and GCP being the primary cloud holders. And also we have model hubs, which we use in order to share and host the model. Hugging Face is one commonly used model hub, which I primarily use. And on top of these frameworks, several end-to-end applications are built in order to meet several different type of business requirements. So before we dwell further and look into the use cases of the banking industry, I like to quickly touch on the life cycle of generative AI models. It has been broadly defined in four phases in the picture here. It always starts with the scope identification. When we talk about the scope, it refers to the combined objective and the requirements definition, which is needed in order to complete the project, and defining the use case and phrasing the business callouts more accurately and narrowly act as a strong base of all the following phases of the projects. The next phase is about selecting the right model. Selecting the right model, as we discussed in the previous slide, is a most crucial phase, and depending on which model which we choose through, it depends on highly dependent on what type of business problem we are solving through. The third phase is about adapting and aligning the model. So, the LLM are capable of carrying multiple tasks, but their ability depends strongly on their size and architecture of the model. We need to think about what function LLM will have in a specific application, and in order to adapt it more for our business adaptability, the model can be further fine tuned. There are different ways of doing it. The first one, of course, is about prompt engineering, where we can play with effective prompts. and in order to get more accurate or precise completion. The second phase is about the fine tuning. Fine tuning actually through the weights and then customize it for our own knowledge repository or the domain specific knowledge. And the third one is about RLHF, which is reinforcement learning through human feedback, where the human feedback are used in order to fix up the the weights of the model. The final stage of the life cycle is, of course, the deployment and augmenting it properly so that we optimize and deploy the model in a most efficient way is the most crucial final stage of each generative AI life cycle. We talked about prompt engineering, and LLM models are trained on generic applications, as we all know, and to customize it further without affecting any of these weights. So, no engineering tool is required actually in order to tweak through the weights, but we can play a lot with the prompts. And when we talk about prompt engineering, it is a key feature. Key feature of any good prompt is that it should contain clear and concise instructions. Also, it should provide adequate instructions about the task to be performed, the explicit role of the model, maybe, or the context of the task, the guidelines sometimes, and even the desired output format. Various prompt engineering techniques are used. Some of these are shown on the slides, where we enrich our prompts more with the kind of examples, the apt examples, and those are called few shot prompting. We also have chain of thought promptings, which are used in order to generate coherent and contextually appropriate text. To further optimize the LLM model, fine tuning the model is the method where we actually adjust the weight of the model. Fine tuning LLM models involve adjusting and adapting a pre trained model to perform a specific task or to cater for a particular domain more effectively. PEFT and LoRa are frequently used fine tuning models, and specifically talking about LoRa is a LoRa based fine tuning model actually freezes your original weight so that you don't have any of the rub outs or any of the overrides on the actual weights, while it also trains on small numbers of parameters which are used in order to make the training more effective. Also, if the requirements are very specific, we can train the model from scratch. This is what exactly Bloomberg did with Bloomberg GPT. And they trained the model almost from the scratch on the financial data. But the only say here is, if you want to train the model almost from the scratch, you need to have that ample amount of data in your repository in order to train the LLM models. And finally, in order to, RLHF is an approach which combines the reinforcement learning techniques with human guidance in order to improve the learning process of the LLM models. It involves training an agent or a model in order to make the decision and take the actions in the new environment while receiving the feedback from human experts. The input human can be provided in the form of rewards or preferences or demonstrations, even examples, and those can help us in order to guide the model learning process. Before we actually go into the use cases of um, you know um, banking industry, I'll quickly touch on responsible AI briefly. So whenever we deal with LLM models, we should question the 3H always, that what kind of responses has been received from these model, and if the completions are 3H, which are listed here, is are they really helpful, are the response which has been got is really honest, and are they harmless, then it actually dwells that we have worked responsibly. And also talking about the principles of responsible AI, they can be classified under different buckets, but if you group it together, there are two major buckets under which we can group through. The first being ethical, and the second being explainable. When we talk about explainable AI, it primarily talks about whether we are able to explain the model which we have developed through, and it can be developed for different kind of domain and different kind of business. But if it comes to explainability, are we able to track back the response which we have got through to the input which we have fed into? That actually talks about the explainability of the model. And finally, there had been several limitations which has been listed through, but three of the most important limitations of generative AI, which we always take into considerations, is the model should not be toxic. It should not be hallucinated, where the response which we get from the model actually looks true like, but it is actually not true. So that is a hallucinated response. And finally, the misuse of the intellectual property. With that, I'll take you through two of the use cases which I have been working primarily in last few months. The first being talks about the writing the SQL queries. The use case sounds very simple, but I will walk you through first the problem statements which we have, and then quickly I'll walk you through the solutions. So, in the industry, right, we have two kind of experts. We have business experts, which include our product owners or the business people or the stakeholders who actually talks only in the business terms. These people don't generally are data rich, and they generally don't even have access to most of the data we have. On a contrary, we also have various data experts in the teams who can be a data analyst or a data engineer or maybe a data scientist and what else. So basically, whenever you start with a problem statement and you think about any of the problem statement, we talk about the business problem on the statement, and we generally go and check through the dashboard, but it is very rare that the answer comes through. So what we do next is we go to our data analyst and we talk through our problem, and then we wait for the response to come, which may take few days or even sometimes few weeks. And this whole process, it goes into a loop, because there are follow-up questions which proceed through each answered questions, and it takes a lot of time in order to freeze the business problem. The second part of it also explains about the optimal sources for the data profiling. So when we are talking about different sources, there can be n number of private or the data sources which are hosted on-prem. Also, we have a lot of third-party vendor data sources. When we talk about data sources, it ranges from the legacy systems like mainframe or AS400. Most of the core banking data are still on mainframes in AS400, and getting the data from them actually means working with very primitive data sets, which actually either will give you the data in a flat files without any metadata, or maybe in some very complex data structures which you have to work logically through, fetch the metadata first, and then you work on the database. And these are some legacy databases which I talked about. But even if you talk about databases, we have structured databases and non-structured databases, and some of these databases are on cloud, and also we have social media rich with data. So if you have to profile the data from all these different sources, the medium part of the slide actually gives us a very simple example where it talks about the business problem is count how many associates who have joined after 20th April 2023 and who reports to Supriya Raman. They actually just need the counts, but in order to answer this business problem, we have to write through SQL query, which actually go into the databases and then go through the attributes, fetch the relevant data, and then return the count. So, in order to automate this whole process and in order to reduce the complexity of the whole process, what we have used is we have used LLM based model, where when we create the prompts are not just the questions which the business is providing, but the prompts are also enriched using the metadata of the databases, which are primarily the schema or the relevance of the databases, and also the prior SQL statements which has been fed by the data analyst. the prior SQL statements which has been fed actually act as the examples to the in while creating few shots prompting. And then this kind of very enriched kind of prompts are something which we fire onto the SQL DB or any kind of databases which we have in order to fetch the data. So this is one primary use case which we are working on, and the second one is about using the generative question and answers on our private knowledge base. So as a banking industry, when we talk about the knowledge base which is primarily hosted on our own premises, we are rich into a lot of documents, but are they readily accessible to the stakeholder, to the business people, or even to the employees, right? It is not. And why it is so? So the first phase of it always start with deciphering the documents, because when you have such huge kind of documentation, the documentation can be as structured as being in the databases and querying it through, but at the same time some of these documentation can also be on your SharePoints, on your Confluences, Jira tickets, or on the dashboards. So primarily taking all such possible documentation which you want to enrich your large language model, we take all such documentation, we segment those documentation into smaller digestive pieces. When we do so, we take into consideration the hierarchy of the documents, or might be the complexity of the documents, or might be the relevance or the context of the documents, depending on what kind of stakeholders we are dealing through. And then we segmentation, it is kind of clustering work which we do there. The third stage is about developing a vector database which actually help us indexing through all these data and providing a quicker access to these documents. And then the fourth stage is about crafting a rich prompt. We talked about the prompt engineering, and of course, the more concise prompting which we can do on this vector database can return more and more accurate data from our own enriched domain specific repositories which we have. So, and the final stage is, of course, choosing the success metrics. When we talk about success metrics, many of these are already been defined for the generative AI model. But what I meant about success metrics is not only the technical aspect of defining the metrics, but also from the domain perspective, because the domain expertise have their own expectations about how these Q&A should be answered, and whether the model is actually living up to that expectation is something which we measure in the final stage. So these are two primary use cases which I had been talking through. With that, I come toward the end of the slide, and I thank you so much for providing me this opportunity. And I hope this had been a good learning session for all of us. Thank you.